All right, we're going to go over this AFDA Inequality and Absolute Value Review. I'm going to go from the start to the finish, so if the video is a little long, go ahead and hit pause, come back to it a little bit later. We're just going to go through it. So in the beginning, a long time ago, we started solving inequalities. And really and truly, what you have to remember when you're solving an inequality is that you have to flip that inequality sign if you're dividing by a negative. Dividing or multiplying. Not adding or subtracting, but dividing or multiplying. So let's go ahead and get started. So, the first thing you're going to do with this first problem is you're going to subtract 4 from both sides. Pull down the 2x, the 4's cancel. Make sure to write that inequality. And then 24 minus 4 is equal to 20. So you didn't have to change anything because you were just subtracting. Make sure you're keeping that inequality the same. And now we want to divide both sides by 2, which is a positive 2. So nothing changes. And you end up with 20 divided by 2 is 10. Now, make sure that you've got your sign the same, your inequality. It's a greater than or equal to 10. All right, now moving on to number 2, it's going to be done the same way, except notice, once we get there, we're going to end up dividing by a negative number. So the first thing, oops, that's an n. The first thing we do is we add the 12. So we have a negative 32 plus 12. You put that in your calculator and you end up with a negative 20. Now, our next step is to divide by this negative 4. When you're dividing by a negative 4, you need to remember that you're going to flip the inequality. The reason is because you're dividing by that negative number. So this is going to become n is less than a positive 5 instead of greater than. Okay? You need to flip the inequality when you divide by a negative sign. All right, number 3. Now number 3, we just get a little more complicated. We've seen problems like this where we've got to distribute, but be careful with what you're distributing. You're taking this negative 4 and you're distributing the negative 4. That negative goes with the 4, not with the 6. So the 6 is just going to come down. Negative 4 times 6 is a negative 24n. Negative 4 times 7 is a negative 28. And then you have greater than or equal to 122. Now, notice that 6 and negative 28 can be combined. Now, hold on. In my calculator, I'm just going to do 6 minus 28. You don't change any signs. You haven't gone across that inequality, which is like that equals. So you're going to end up with negative 24 and minus 22 is greater than or equal to a 122. Okay, so I haven't had to do anything with the inequality. I just combined my like terms. I didn't change any signs yet. Now, as I'm going to go across this inequality, I am going to change the sign. So I'm going to add 22 to both sides. And 122 plus 22 is 144. Divide by a negative 24. Now, whenever you say divide by a negative, remember you've got to flip the inequality. So you're going to have n is less than or equal to, notice how that flipped, and 144 divided by a negative 24, in my calculator I got the answer to be 6. Negative 6. All right, number 4. Number 4, same kind of thing. I'm going to distribute this 5. So I get 30 plus 15r plus 7 is less than or equal to 127. Now, the 30 and the 7 are on the same side, so I'm going to combine those by adding them. I'm not changing the sign. I'm just combining them because they're on the same side of that equal sign. Now, I need to move that over, so I'm going to subtract 37 from both sides. Notice how each time I'm keeping this inequality. I don't change it all of a sudden to an equal sign. 127 minus 37 is 90. Now I'm going to divide both sides by a positive 15. Now I'm dividing by a positive number so that inequality stays the same. 90 divided by 15 is a 6. All right, let's look at the last one of these problems. Number 5. Ooh, we've got p's on both sides. So the first thing we want to do is we want to distribute this 3. 3p minus 9 minus 5p is less than a negative 3p minus 6. Now look here, you've got a 3p and a negative 5p. Those need to go together. Now, when they go together, they don't change signs. You're doing a 3 minus a 5. You get a negative 2p over there. So we have negative 2p minus 9 is less than a negative 3p minus 6. Okay. All right, so I need to combine my p's, and I'm going to be putting them, with each other. I got to change the sign because I'm going over the equal sign. So I'm going to add the 3p to both sides. It really doesn't matter which way you go, but this way it's going to give you a positive 1p. Those will cancel. I'm going to bring that up here. P minus 9 is less than a negative 6. So I just wrote the same thing. To finish off the problem, you're going to add 9 to both sides. P is less than a positive 3. All right, so that's solving the inequality portion. Now on the test, all the questions are going to be mixed up in different orders. So you're going to have some that look like this, where you just have inequalities. You just solve it the normal way you do. Okay? All right, so 6 and 7. These are just equal sign equations, but for a while we were working with how do we solve equations with fractions in them. So they look a little bit different, so they have a different approach. For number 6, the whole thing is divided by 2, so we can't add 5 until we move this 2 away. So we're going to multiply both sides by 2. It cancels over here, leaving you with x minus 5. 10 times 2 is equal to 20. You add your 5 and you're done. X is equal to 25. Now with number 7, you can't multiply by 3 yet. You can't multiply by 3 yet until you move this 5. Now if you did multiply by 3, which you could do, you'd have to multiply this one, and this one. You'd have to multiply everything by 3. So to make life easier, I'm going to move the 5 first. 13 minus 5 is 8. Now I can multiply both sides by 3. Cancel over here. Don't forget that 2 is still there. And then at the end, you can divide by 2. And you get that x is equal to 12. All right, so that's just solving with fractions in them. I don't think you have a ton of fractions on the test, maybe 1 or 2, just kind of like what we saw right here. All right, moving on to 8 and 9. Now, this one says solve the compound inequality and graph the answers. Now, we know after doing absolute value inequalities that these are and or problems, but they're already set up for you, so you just have to solve them. For this one, you just solve 2 separate problems like normal. So this one, you add the 5. 7x is greater than or equal to 70. Divide by 7. You get x is greater than or equal to 10. And then you get your OR problem. Add your 2. You get negative 3x is greater than or equal to 0. Negative 2 plus 2 is 0. Divide by a negative 3. Ooh, when we divide by a negative, we need to remember to flip the inequality. Okay? So x is less than or equal to, well, 0 over negative 3 is just 0. And if you don't remember that, you can just put it in your calculator. Your calculator will tell you. If you had something where the 0 was in the denominator, your calculator would say, error, you can't divide by a 0. Okay? So it would tell you what the problem was. Okay? All right, now, this is an OR problem. We know that on OR problems, they're going to go in opposite directions. Now, make sure you're putting your numbers in the right spot. Not going to have to worry about that on the test, but on some of these quizzes, you want to make sure you've got the 0 on the left-hand side of the 10, because 10 is bigger than 0. Now, these both have equal signs, so they're both closed. X is smaller than 0, so it's going to go to the left, because the mouth ate the 0. X is bigger than 10, so it's going to go to the right, because the mouth is eating the x. So there is your graph for an OR equation. All right, looking at number 9, that's our AND equation. So we want to subtract the 6, but we can't just subtract the 6 from the right. We got to subtract the 6 over here as well. So we have a negative 50 minus a 6, which is minus 56. Oops, no equals. Careful with that. Negative 8 minus 6 is a negative 14. So now you've changed all of the numbers. Okay, you subtracted the 6 from the middle, so it was gone, and then you subtracted it from the two ends. Now we're going to divide all sides by 7. Negative 56 divided by 7 is a negative 8. And that's a negative 2. Now, had that 7 been negative, we would have changed both inequalities. But it wasn't negative, so we didn't change the inequalities. We have a negative 8 and we have a negative 2. Our 0 would be somewhere over here. Okay? Now, both of these circles are open because there's no equal sign. Notice over here you had an equal sign, closed circle. No equal sign, open circle. The X is in between the negative 8 and the 2, so we're going to highlight between the negative 8 and the 2. All right, let's go to the next page. The next page, number 10, they're asking you to write the compound inequality. So basically what you're doing is for number 8 and number 9, you found them and then graphed them. Now we're going from the graph, you're going to write the equation. So for number 10, because they're going in different directions, you know that it's going to be an OR problem. All right? Now, X is going to be less than 7, because look at all of this, all of these numbers, 6, 5, 4, 3, those are all numbers that are less than 7. So X is less than 7. Now notice I don't have an equal sign, because it's an open circle. Open circle, no equal sign. Now this one, X is going to be bigger or greater than 11, because 12, 13, 14, those are bigger than 11. Now notice I put an equal sign because it was a closed circle. So X is less than 7 or X is greater than or equal to 11. All right, let's look at number 11. Number 11, we know we have an AND problem. So we know that the X is going to be in the middle, and we know we have these less than signs. Now look at this negative 3. It's got an equal sign. This positive 3 does not. Now, in a lot of cases, these are so easy. They're kind of like our domain and our range. You're just going to write the numbers on either side, and you're done. Okay, so it's just as you see it. So a lot of cases, the 11 AND problems, they're easier than the OR problems. Okay. All right, moving on. Absolute value equations. Now notice the difference between an equal sign and then the greater than or less than. The equal sign, you're just going to set one of them equal to the positive and one of them equal to the negative. So you're going to have k minus 10 is equal to positive 3, and k minus 10 is equal to negative 3. That's the thing that you're going to change the sign of. K minus 10 equals positive and k minus 10 equals negative. Now, to solve these, you got to make sure to add 10. So k is equal to 13. Add 10. K is equal to 7. And then you're done. So when you're solving absolute value equations that have equal signs, you just have to set them equal to the positive number and then the negative number. Now, with number 13, we can't do a positive 4 and a negative 4 because this negative 3 is hanging out outside of the absolute value. So we have to make sure to combine anything that's outside of the absolute value before we do our equal sign. So 4 plus 3 is equal to 7. Now I can say that x plus 7 is equal to 7, and x plus 7 is equal to negative 7. So this is what I did, the positive version and the negative version. Now make sure you finish it off. Subtract 7 from both sides. X is equal to 0. Subtract 7 from both sides. X is equal to negative 14. So for these absolute value problems, you're going to have two answers. All right, look at 14. This is all inside the absolute value. This is outside. So we don't have to move anything. We can just go ahead and write our equation. So positive 11 on one side, negative 11 on the other. Now you're going to solve the equation the same way. You're going to add 1 and divide by a negative 2. Now, we don't have an inequality, so we don't have to worry about flipping an inequality. It's just going to be x is equal to negative 6. Here we add 1 and divide by a negative 2, and x is equal to positive 5. So your two answers are negative 6 and positive 5. Alright, so now we're moving into absolute value inequalities. Now, remember, a less than is an and problem. Remember the word land. A greater than is an or problem. Remember the word or. And we're going to write them. They're going to end up like these two equations right here. So let's take a look. Number 15. You got your absolute value all by itself and the h over here all by itself. And this is a less than sign. So it's going to be an and problem. Now, when I write an and problem, the original equation stays. I just throw an extra negative 8 and a less than equal sign in the front. That's how I make the and problem. Negative 8 less than or equal to p plus 4 less than or equal to 8. Now you're not done. You need the p by itself in the middle. So you're going to subtract the 4 from all sides. Negative 8 minus 4 is negative 12. The p is then alone in the middle. And the 8 minus 4 is the 4. So you're negative 12 less than or equal to p less than or equal to 4. Now, number 16. I can't get started yet writing the and or the or because this 2 is outside of the absolute value. So I have to combine that with a 16. We have to divide both sides by 2 first. Now that I have the absolute value of x minus 2 is greater than 8, now I know that this is an or problem. It's an or problem because it's greater than, not the word land, so it's got to be an or. Now, when we do an or problem, we write the equation as it is, and then we say or it could be the negative 8. You got to flip your inequality. Notice I changed the inequality and I changed the sign. Okay, because think about the or problems. They have to go in separate directions. Well, if the signs are going in the same direction, they're not going to go in separate directions. So you have to flip that inequality to get the graph to go in the other direction. Now, make sure you solve. Add 2 to both sides, x is greater than 10, or add 2 to both sides, x is less than negative 6. Okay, so x is greater than 10 or x is less than negative 6. All right, number 17. Excuse me. Again, we can't get started because this 5 is here and it's outside of the absolute value. We've got to add the 5 first. Absolute value of x minus 2 is less than a positive 3. Negative 2 plus 5 is a 3. Now we see this less than and we know that it's an and problem. So that means I write it as normal, but I tack on that negative 3 to the front. I want the x in the middle for my and problem. And then I got to add my 2 to both sides. Well, all sides. Negative 1 less than x less than 5. All right, number 18. There's lots of stuff outside of this absolute value, so I have to move those things first. Now, if you had the equation that looked like this, the first step you would do is subtract the 10, and then you would divide by 9. You're going to do the exact same thing here. The first thing you're going to do is subtract the 10. Then you're going to divide by 9. (45 divided by 9 is 5. Okay? I might actually write that over here. Okay? Just so I have some room to finish the problem. All right, now we can see that this is an and problem. Okay? Because of the less than sign. So we have the negative 5 is less than the x plus 8 is less than the 5. And now to solve the problem, you just subtract the 8 from all sides. So you get a negative 13 is less than x is less than a negative 3. All right, got 3 more problems left. We're almost there. Number 19, still an absolute value inequality, but just like number 18, we've got all this stuff out here that we need to move first. So just like with the last one, we're going to subtract the 8 from both sides. 24 minus 8 is 16. Now you need to divide both sides by 4. And you get 16 divided by 4 is 4. Now, this is an OR problem. You see that right there? It's an OR problem. So I've got 6 minus 2x is greater than or equal to 4. Leave it the same as it is. Or 6 minus 2x. Now remember, our graph has to go in the other direction. So we have to flip that inequality and make it less than or equal to negative 4. So we have greater than positive 4, less than or equal to negative 4. Now we can solve this problem. Subtract your 6 from both sides. Negative 2x is greater than or equal to a negative 2, because 4 minus 6 is negative 2. And now we're going to divide by the negative 2. Now, oh dear, we've got inequalities and we're dividing by a negative. So I have to flip that inequality and say that it's going to be x is less than or equal to 1. So don't forget you had to flip the inequality. Okay? So now we're going to do this one. And it's going to be done the exact same way, which means we're going to have to flip this inequality as well. Okay, because again, I'm going to divide by a negative 2. So x is going to be greater than or equal to a positive 5. Okay, now they're still going in opposite directions. If I were to graph these, this would go that way for 1 and this would go this way for 5. So it would be an OR equation. So just be really careful with those inequalities. All right, our last two, number 20 and 21. Number 20, you've got 2 equations right here. We've got p plus 4 is less than or equal to 1, or p minus 1 is greater than 1. I'm writing them over there so I have room to work them out. So subtract 4 from both sides. I find out that p is less than or equal to a negative 3. Then I add my 1 to both sides, and I find out that p is greater than 2. Now let's go ahead and graph this thing. We've got a negative 3 and we have a positive 2. We have an open circle at positive 2 and p is bigger than it. We have a closed circle at negative 3 and p is smaller than it. Now the question is, which value is the solution to the compound inequality? Now, just like on that Desmos thing we had to do, a solution is going to be something that's inside this shaded area. So what we're going to do is we're going to place all these numbers and see which one's in the shaded area. The 2 is going to be right here. That's an open circle. The negative 5 would be right here. Oh, the 0 is somewhere around in here. And then a negative 2 would be somewhere right here. Now look, not in the shaded area, not in the shaded area. This has an open circle, which means it is not going to work either. This is the one that's in the shaded area. So any number in the shaded area, in either shaded area, would be a solution. But in this case, negative 5 was the only one that was found in that shaded area. All right, let's do the same thing with number 21. Except this one's an AND problem. I'm just recopying the problem so I have enough room to work. Okay? So the first thing I have to do is I have to subtract the 1 from all sides. Negative 8 is less than 2x is less than or equal to 4. And then I'm going to divide by 2 on all accounts. So I get negative 4 is less than x is less than or equal to 2. So if I were to graph this, it's going to look like this. Open circle at negative 4, closed circle at 2. The x is in the middle. Okay? Now we want to know which one of these solutions over here falls in this shaded region. Well, let's plot them. We got negative 4 right here. A positive 3 would be over here. A 0 would be here, and a negative 5 would be over here. Okay? 0 is the only one that's falling inside the shaded region. -5 doesn't work. It's out here not shaded. -4 doesn't work because it has an open circle. Open circle means it doesn't equal that number. And then a +3, well, that's past this 2, so that one doesn't work either. The only one that works is 0. All right, so now you should be ready to go ahead and take the test. Now remember, you get one chance, so take your time, work through the problems, that they're all multiple choice, and good luck.